About 65 million years ago, a really big asteroid struck Earth. Well, how big, you ask? It was big enough to cause a global catastrophic event, wiping out 80% of the animal species. It's been a lifelong mission of astronomers, scientists, and engineers to prevent another event such as that from happening again. That is where NASA's double asteroid redirection test mission comes into play. Project DART is NASA's very first planetary defense mission. Don't worry, there's no asteroid that's going to collide with Earth within the next 6 months and 14 days. DART's target is Dimorphos, a moonlet asteroid that's roughly 160 meters in diameter. It is a part of a binary asteroid system, and it is orbiting a much larger asteroid called Dynamis. Again, I just want to clarify, Dynamis and Dimorphos are not on a path to collide with Earth. This is only a test mission. With the help of SpaceX Falcon 9 rockets, NASA's DART spacecraft launched on November 24, 2021. It is expected to reach Dimorphos on September 26, 2022.
Planetary defense test to intentionally crash into an asteroid.
Now you may be wondering, how exactly does all of this work? Well, here's Cal to explain it to you.
Thank you, Neil. So yeah, DART will spend about 10 months in cruise and will reach Dimorphos when it's closest to Earth on the Dynamis system. So if you can see Dynamis here, and this is Dimorphos, the DART spacecraft will reach Dimorphos when it's on the orbiting side facing Earth to make accuracy easier. About 10 days prior to reaching Dimorphos, they will release the LICHA cube, which is short for Light Italian CubeSat for Imaging of Asteroids Cube, and is basically a CubeSat or satellite that will be equipped with 2 cameras to autonomously track the DART and view its impact and aftermath. About 4 hours before impact, they will turn on the smart navigation technology on the DART spacecraft that will allow them to guide its path into the asteroid, because they don't actually see the Dimorphos asteroid until about an hour before expected collision. Since it's about 305 meters smaller than Dynamis, that's about 390 meters. At that point, they're going to stop tracking Dynamis and will switch over to track Dimorphos, which then only appears as a small pixel on their camera on board the DART spacecraft. So you can see why it was important for them to first track the bigger asteroid Dynamis, then switch over to Dimorphos after it was at a reasonable distance for the camera and its smart navigation technology to see. The whole time, the spacecraft will autonomously guide itself into Dimorphos and then it'll make impact. And as Neil talked about earlier, the mission is about demonstrating deflection of an asteroid by changing its course. So NASA made requirements in order to declare a mission success, where 1. It'll make impact on Dimorphos between September 25th to October 2nd of 2022. Number 2, cause at least a 10% change in its binary orbit period from impact. 3, have the aftermath observations of the binary period equate to less than a 10% margin error. And 4, to measure the momentum transfer efficiency of the impact and the resulting aftermath of impact. Now, the most important requirement of changing its binary orbit period. We first have to note that the orbit period of Dimorphos is approximately 11 hours and 54 minutes, so they have to make at least an 11.4 minute change. To achieve this, the guys at NASA has a baseline plan to impact Dimorphos at a velocity of 6.6 kilometers per second or 15,000 miles per hour. And by the way, Dimorphos weighs about 1,344 pounds, so it would only be a small nudge to this massive asteroid. But that small nudge is capable of changing the asteroid's orbit period, which could help scientists at NASA develop technology that could be employed in the future to prevent an asteroid from impacting Earth. And this technique is actually referred to as the kinetic impactor technique. Moments before impact, the DART spacecraft will measure the impact conditions such as the terrain of the asteroid, whether it's sloping or if there are any boulders nearby. And after impact, they would begin measuring the orbit period change with telescopic measurements from Earth. Also subsequent to impact, the camera on board the LICHA cube will get imaging of the DART impact and its ejecta plume. And an ejecta plume is basically the resulting projectile of the explosion. So these images would help determine the vector momentum transfer from the impact by measuring the plume structure and its characteristics as it evolves over time. This is an important step in the mission because we have to remember that the DART spacecraft will hit the asteroid at about 15,000 miles per hour. As a result, millions of material will be blasted off, so they need to know how much material there will be, how fast it will be going, and where it's headed. So with that information, together with the ones gathered from the DART spacecraft, will allow them to determine the momentum transfer from the impact. It's such a mind-blowing mission that we're evolving into planetary defense technology, which you would only really imagine in movies and sci-fi films. But it's still important to note the impact it has on society, so I'm now going to hand it over to Johnny, who will talk to you about that. Thank you.
Why, thank you, Kyle. After hearing Kyle talk about sending spacecrafts into space to hit asteroids, you guys must be wondering, why in the heck are they spending $324.5 million to just explode a spacecraft? You might feel as if they are taking their tax money, crumpling it into a ball, and tossing it into the garbage. But what you guys don't know is that this garbage bin isn't even really a garbage bin. It is a bin of the future. NASA and all these other space agencies are spending this $324.5 million and investing it into the future. There's this funny tweet that Elon Musk posted on Twitter saying, "Avenge the dinosaurs." And as silly as this may sound, he's not that far off from the truth. We aren't saying avenge the dinosaurs, as in killing all the asteroids in space. However, we are instead ensuring that we will never end up in a similar situation to the dinosaurs. Let's pretend this globe is the Earth. And let's pretend this monkey is me. This aluminum ball is a dinosaur killer, and it's coming for us all. Me as a clueless sleeping monkey, I'm not expecting anything. Little do I know that if this asteroid comes in contact with the Earth, I am doomed for whoosh. However, if NASA makes this handy dandy spacecraft that can change the trajectory of this asteroid, sleeping me will continue to dream of his bananas. With my 1-to-1 replica of this NASA DART spacecraft, the people on Earth can detect the asteroid in months in advance. They will send their ship up, and when it makes contact with the asteroid will shift in a minuscule amount. Yet, since the asteroid is so far away from the Earth, as the spacecraft hits, the asteroid will safely pass the Earth rather than hit it. Even if there is a 0.1% chance of the asteroid hitting Earth, and just a 0.00001% chance of the asteroid being as large as the asteroid that killed the dinosaurs, it is always better to be prepared. As a society, we tend to point and laugh at the people who are overly cautious and worry about the worst that is unlikely to happen. Yet, as the problem comes to us, we panic and depend on the ones who have prepared. On September 16, 2021, just last year, there was an undetected asteroid that entered the Earth's atmosphere. An asteroid in the size range of 42 meters to 94 meters in diameter, named 2021 SG, came out of nowhere. We were not prepared for it. The asteroid came from the direction of the sun, and due to this, NASA was unable to detect it until a day later. The asteroid luckily disintegrated over time as it entered the Earth's atmosphere and got closer to the Earth. Going at such fast speeds, it began to burn and disintegrate. We were lucky enough for this asteroid to not make impact with the Earth, for that would have been disastrous. Another time we were awakened about our fears of space was in 2013 with the
Chelyabinsk
meteor. A part of this meteor had broken off and made an asteroid with a diameter of 17 meters in length. With the sheer mass and speed at which the asteroid was going, the shockwave it generated shattered glass and injured about 1,200 people. With people such as NASA and these other space agencies putting on the pedals to bring forward our technology, we will be able to come closer to living in a safer world. Even if the odds of the asteroid coming to Earth are so little, I very much would like to be on the team in which we have countermeasures. As Benjamin Disraeli said, I am prepared for the worst but hope for the best. Let's hear from Neil one more time, in which he will bring us home. Let's hear it, Neil.
Whoa, that was a lot of information thrown out at you. Well, here's a little recap. Number 1, DART is NASA's very first planetary defense mission. It is a mission to test out how effective the kinetic impactor technique really is. Number 2, its target is Dimorphos, a moonlet asteroid that's orbiting a much larger asteroid called Dynamis. Number 3, DART was launched on November 24, 2021. It will collide with Dimorphos on September 26, 2022 with a speed of 15,000 miles per hour. NASA's technologies such as the Lisha Cube and Smart Nav will help us determine how effective the technique really is. And although DART is expensive, all we are really doing is investing in our future. We are investing in technologies to help us prevent human extinction. Don't think of it as a billion-dollar project. Think of it as buying plants that shoot out peace just in case there was a zombie apocalypse. That's all for today, and remember, stay safe.